Hey, what's going on, guys? In this video we are going to see how to solve a Cauchy-Euler initial value problem. First of all, we have to know how to figure out a Cauchy-Euler differential equation. To figure out a Cauchy-Euler differential equation, what we have to do is we have to look at this x power and y order. If the x power and y order matches with each other, it's a Cauchy-Euler. Here we have x power 2 and y order. This is a second order differential equation. This is second order, and then x power 1 we have first order, and here x power 0, because we don't have any x, it means x power 0, and this is zeroth order. So all the powers and orders are matching each other. It means this is a Cauchy-Euler differential equation. Now here we have an initial value problem. Now first we have to pick up a, b, c value. A, b, c values are the coefficient in front of each of these, like x square, y, like this x power and order. If you have any number in front of this, that's our coefficient. Here for the first one we don't have anything, it means that's 1, a is equal to 1, and b also we don't have anything in front, it means b is also equal to 1, and c we don't have anything in front of that one, it's also 1. Okay, we have a1, b1, c1, so we have to put it in an arbitrary equation that's look like this: a m minus 1 plus b m plus c. So this is our characteristic equation. In this one we have to plug this a, b, c value and figure out whether it's giving distinct real roots or equal real roots, or it's giving a complex number. Based on that, our solution is going to differ. Now let's see what we get from this. Let's plug the a, b, c value. A is 1, so this is going to be just m times m minus 1, and b is also 1, so this is going to be just m right here, and c is 1, so this is going to be just 1 right here. Now m times m minus 1, that's going to be m square minus m plus 1, that's equal to 0. Here you can see this plus m and minus m cancels each other, so we will get m square plus 1 is equal to 0, plus 1 is equal to 0, so m square is going to be equal to minus 1. Therefore m is going to be equal to square root of minus 1. This is going to be plus or minus square root of minus 1. So we can see this plus or minus I. Here we have a complex roots, right? Complex roots. So whenever we have complex roots, the general solution of the differential equation is going to look like this. We will have the general solution that will be x power alpha times c1 cos beta ln x plus c2 sin beta ln x. Now this is only for Cauchy-Euler. If we have a normal second order differential equation, the pattern will be e power alpha x and then multiply by c1 cos beta x, then plus c2 sin beta x. Here the difference is here we have ln, and also this is x power alpha. Instead of e power alpha x, we have x power alpha. Okay, now let's go ahead and plug the values. Here if we write this one in terms of alpha and beta, this is going to be equivalent to 0 because we don't have any real number, so this is going to be just 0 plus minus, and we have imaginary number that's just 1 I. Here alpha is this first term, and this is our beta, so we can plug it in this equation, and if we can neglect this x power alpha because this is going to be just x power 0, that's going to be just 1. Now let's go ahead and plug other values, this 1 and 1 for beta, so both of them will be just cos ln x and sin ln x. I continue this one right here. Let's use a different color. Let's use this green or this one. Okay, now I continue this one here. Y of x is equal to, the general solution is going to be c1, and beta is 1 for both of them, so we can directly write c1 cos ln x, and then plus c2 sin ln x. Now this is general solution, but here we have the initial values are given, so we have to find out the particular solution. To find out the particular solution, we have to plug these values. For the first one, if you look at this one, y of 1 is equal to 1. It means when x is 1, this is our x value, y is equal to 1. Okay, so we can directly plug this one, since we don't have any derivative or anything. We can directly directly plug this one in this equation and find out one of these. Like we can, our purpose is, in particular solution, our purpose is to find out this C1 and C2. Now let's plug this one and see which one we can find from that. Okay, y of x is 1. 1 is equal to C1 and cos ln of x. Ln of x is 1. Ln of 1 is equal to 0. So C1 cos 0 plus C2 sine 0. And we know that sine 0 is equal to 0. So the whole term will cancel. Cos 0 is equal to 1. So C1 is equal to 1. We found out the first constant. Now we have to see whether we can find the C2. To do that, we have to apply this y prime of 1 is equal to 2. Again, this is our x value and this is our y value. Now to apply this one in this equation, we have to find the derivative first, because this is y prime of 1. So we have to take the derivative of this one first. Let's go ahead and take the derivative. Y prime of x is going to be equivalent to C1. And if you take the derivative of this cos ln x, this is going to be a chain rule. First we have to take the outer derivative. So that's going to give us minus sine x, minus sine ln x. And inside derivative of this ln x, that's going to be just 1 over x. And then that's it for the first part. Then C2, again outer derivative, that's going to be just cos ln x, and inside derivative, that's 1 over x. So we can just put it in the x in the denominator. Now let's write this one in a better way. Y prime of x is equal to minus C1 sine ln x divided by x plus C2 cos ln x divided by x. Okay, now I plug this y prime of 1 for this one. If you plug 1 for these x values, this is going to be just 0, because minus, let's plug the value. Okay, here this is 2. 2 is equal to minus C1 sine ln of 1 is going to be just 0. So I put it 0 right here. X plus C2 c cos ln of 1, again 0. This is going to be cos 0 divided by x. And here you can see sine 0 is going to be 0. So the whole thing will become 0. And here we have cos 0, that's going to be 1. And we know that x is equal to 1. So we can plug that 1 also right here. Okay, let's get rid of this x and put 1. Okay, 1. Now we know that C2 is equal to 2. C2 is equal to 2 because cos 0 is 1 and this is 1. So C2 is equal to 2. We found out C1 and C2, so we can write our particular solution. The particular solution of this differential equation is going to be y of x is equal to C1. C1 is equal to just 1. C1 is equal to 1. So this is going to be cos ln x plus C2. C2 is 2. 2 sine ln x. And this is going to be our particular solution of this differential equation. And that's how we do that. I hope you guys find this video helpful, and if you are trying to learn this differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.